Hello everyone, this is Alan Farsad greeting you from the beautiful Santa Barbara. This video is going over the Chameleon system. It is a fully automated laboratory permeameter. The picture on the left shows a 5-station Chameleon system. The picture on the right shows a single-station Chameleon system. The system is also known as the flow cell system, the Darcy system, or soil core saturated hydraulic conductivity system. Up to 20 Chameleon units can be connected to a single computer and run independently. Both the constant head and the falling head method can be performed automatically with the Chameleon. The schematic on the left shows the constant head setup here. The system consists of a Marriott bubble tower reservoir and a flow cell containing the soil core. The monitor pressure vacuum transducer is connected to the top of the Marriott bubbler. The measurement resolution of the monitor is 1 millimeter of water height, which is equal to a tenth of millibar. The vacuum measurements are transferred to the software application using a USB cable. The schematic on the right shows a falling head setup. The monitor transducer is connected to the base of the reservoir and it measures pressure. Mobility of the monitor transducer is one of the unique features of the Chameleon. This is the reason for the Chameleon being able to perform both the falling head and the constant head methods completely automatically. As a matter of fact, the monitor transducer can be connected to a third-party reservoir and the system still works. It's worth mentioning that the competing products have a fixed pressure transducer at the base of the reservoir, and that is why they are not able to perform a constant head method automatically, which is, by the way, the more accurate method. Both falling head and constant head methods are 100% automated, as I explained in the previous slide. Second, Chameleon is scalable. That means that up to 20 units of Chameleon can be connected to a single computer. It is worth mentioning that each Chameleon unit has its own independent application window. Therefore, you can run each Chameleon unit 100% independently. Third, the Chameleon is optimizable. For example, you can actually modify the physical components and optimize the system for measuring extremely slow soils in a much shorter time compared to the standard setup. You can also modify the Chameleon and increase the water supply rate several times. This will allow you to measure very fast soils with the Chameleon. But the Chameleon is also adaptable. This means that it can adapt third-party components. Fourth, the Chameleon is a perfect combination of the following features. Outstanding precision thanks to its top-of-the-line pressure transducer, high resolution 1 millimeter of water, wide application range. The standard system can measure from medium sand 10 to the minus 3 meters per second all the way to fine silt, which is 10 to the minus 8, which is well beyond the application range of the competing products. Moreover, you can modify a standard setup and cover an even wider range of application. Convenience. The Chameleon is extremely easy to set up and use. Please watch the instructional video for more details. The Chameleon is also cost-effective. Thanks to its smart design, the Chameleon is not that expensive to manufacture. That is why we are able to offer it at a great price. That is about a third or even a fourth of the competing products. Okay, we got familiar with the physical parts. Now let's take a quick look at the software application. I am going to be very brief here. More detailed explanations can be found in the Chameleon Quick Start Guide. Here you can see the main form or window of the Chameleon software application. It is divided into 3 sections: the parameters area, reading table, and the graph area. The first thing is to choose the measurement method. It can be falling head or constant head. Here the constant head method is selected. Then you need to set the duration of the measurement campaign. Next, set the reading parameters, including the reservoir inside diameter, soil sample core diameter, soil sample length, and overhead pressure. All these parameters are shown in the schematic here for your convenience. The schematic also instructs you to set up the physical components in the correct way. Once everything is ready, open the reservoir valve, click Start, and sit back and relax. The Chameleon will let you know when the measurement is done. All readings, parameters, notes, and results are saved automatically. They can also be easily exported to a CSV file. A straight line is an indication of a correct constant head reading. If the graph is not a straight line, you need to redo the measurement campaign. Now, if you select a falling head method, then this is the form you'll see. Here you can determine the endpoint of the reading campaign. It should be close to the zero head height, as you can see in the schematic. Again, complete explanation of it can be found in the user manual. Enter all the parameters here. Set up the physical components of the system according to the schematic, and then click the Start button. It is as simple as that. The falling head method will create a decreasing exponential trend line. Again, if the trend line does not look right, then you need to redo the measurement campaign. The message here says that the reading campaign is completed and the results are calculated, as you can see here. Thank you so very much for watching this video. I hope you found it helpful and interesting. Please send us your comments and questions. Our email is sales@soilmoisture.com. You can also call us at 805-964-3525. This is Alan Farsad. Take care. Goodbye.